Is the greenest building the one already standing? This synthesis map was created by Shaun, Alfonso, Benson, Véronique, Claude, and Samah Kamalmaz from the Strategic Foresight and Innovation Master's Program at OCAD University in Toronto. This synthesis map explores the whole life carbon profile of buildings to better understand the influences, challenges, and opportunities for reducing carbon emissions in the Canadian building sector. 39% of global greenhouse gas emissions and 17% of Canada's emissions are produced by the building sector. Buildings contribute to greenhouse gas emissions through embodied carbon and operational carbon, together known as whole-life carbon emissions. As power grids in Canada decarbonize and on-site energy generation becomes more common, embodied carbon will contribute a greater percentage to a building's carbon profile and be a more impactful avenue for intervention. However, delaying action on embodied carbon risks locking in a higher carbon profile in the built environment for the next 50 to 60 years, the typical lifespan of Canadian buildings. Each section in this map explores a theme and is labeled with a set of icons that identify key stakeholders involved in each of the themes. Under whole life carbon emissions of buildings, the map features a typical multi-story building with a sample of construction materials and the carbon emissions associated with their extraction, manufacturing, demolition, recycling, and transportation to landfills. In other words, embodied carbon. Above the building, we show the typical energy profile of residential buildings in Canada and the associated carbon emissions, also known as operational carbon. Under tracking and reporting of carbon emissions, we explore how the complexity of tracking carbon in supply chains, combined with the lack of regulatory standards around responsible reporting, hinders informed investment. We then look at behavioral archetypes contributing to carbon emissions related to policy interventions, media, industry competitions, and awards, and these are explored through causal loops and systems archetypes. Next, we explore why we built this way through a causal layered analysis diagram that highlights the social, economic, and demographic forces that shape our buildings and the way we assign value as a society. At the far right side of the map, we map the different policy interventions based on their relative power as system leverage points to meet climate targets, in addition to existing systemic counter-incentives that hinder our progress towards meeting climate targets. We hope this map brings attention to the importance of considering whole-life carbon in decisions and policy interventions for the building sector. Reaching our 2030 climate targets is possible, but only by addressing the underlying structures and societal values of our current system. Decarbonizing the built environment does not require us to rebuild 15 million structures in Canada to a new low-carbon standard, but rather to shift our perspective and learn to value carbon emissions avoided as much as we value the latest in building design and technology. And from that lens, the greenest building may just be the one already standing.